reflexive? No, I'm not an ancestor of myself. Okay? Is L reflexive? I hope so. I hope so. Okay, good. So is L symmetric? If Bonnie likes Jenny, does that mean Jenny likes Bonnie? Not necessarily, right? Okay, very good. And there's a third relationship that you might hope to be true as well for an equivalence. You want to say a bunch of objects are equal, and I know this is in, these two things are in the relation, these two things are in the relation. What's a third thing you might hope to be true? Katie? Okay, good. If A is related to B and B is related to C, then A better be related to C. This is called transitivity, okay, the transitive property. Okay, so these are the three things that you hope to be true. And I'll put a period here and commas just to emphasize the sentence is complete. Okay, and you often write something like this. The equivalence relations are often denoted by something that looks like an equal sign, right? It might be tilde, or it might be double tilde, or sometimes tilde with an equals. There's a lot of ways to write equivalences. Okay, you generally avoid using the equal sign because it's reserved for actual identity. Okay. Okay, good. So that's an important example of an equivalence of a relation. And I'll just mention one other important example, although this is the one we'll want to deal with today. As an aside, here's another important example of a relation. So I claim a function is also a relation. So a function from, let's say, A to B is a relation. So, okay, now, of course, when you think of a function, you think of maybe something like the letter F, right? And you think of what? Well, you think of F. You often write F colon A arrow B, right? What's true about a function? What makes a function a function? Yes, Jenny.
If you're going to think of it as a relation that for every element in A, there's only one pair, AB, which is part of it.
Very good. So each input gets sent to one and only to one out to unique inputs have unique outputs, right? So one way to think about it is if I apply a function to a particular element here, let's say I put in a person and I get out their bank account, the money in their bank account. Then you'd hope that every time you enter the person, what you get out is still the same number, okay? Which is not necessarily true about bank accounts over time, right? If you want to turn that into a function, you probably want to add another input, which is the time, right? Okay, but the idea is it's a rule that assigns to every element here a unique element here. Let me just convince you that this is also a relation. Right, so it's a relation such that, I'm just going to write it down the way Jenny wrote it, said it, and that is if A F B and A F B prime, then what do you hope to be true? What should be true if it's going to be a function? Then B equals B prime. It has a unique output. So this is a rule. This is how we capture very formally the idea that it's a rule that assigns to each A in little a in big A unique B, little b, in B. Okay? Now, of course, we never write functions this way. We usually write functions this way. F of A equals B. Okay, but that's just a notation that describes this relation. All right. Very good. Everybody with me? Excellent. So we're going to take a 1-minute break, 2-minute break, stretch break. And after the break, we're going to construct the rational numbers. Okay? And I'm